Which number is next? Okay, let's have a look. Right here, we have 1, 2, 3, 4, 5, but the next number is 8. In fact, if you stop the sequence right here and ask people what the next number is, it will be much more interesting, but you will also make a lot of people more upset. Anyways, though, so we do have more numbers here. We have the next number being 7, and then 16. Based on this, can we see what's going on? I think it's more fair now, right? For me, I think the biggest hint is seeing the 8 to 16, which I can look at this as multiplied by 2. And if you go back though, 4 times 2 is 8. And then if you look at the 2 multiplied by 2, we do get a 4. So I will have to multiply by 2, but we still have to figure out this missing number. But that suggests us to look at the rest. 1, 3, 5, 7. That's just all the odd numbers. So the next one right here will be 9. And of course, you can also look at this as plus 2. Plus 2, plus 2. So you have to alternate this thing. Yes, and then the next one is you take the 16, multiply by 2. So you end up with 32. And then so on, so on, so on. Yes, sometimes when you have a sequence, you have to break it down into the odd number terms and also the even number terms. Let's see how we can write a formula for that, yeah? Okay, an for this sequence. And to write a formula, I usually recommend my students to write down the number of terms, like the followings. This right here to us is let's say 1. So this is A1, and then A2, A3. So just write down whichever term is A5, A6, and so on. Our goal is to make sure A1 gives you 1, A2 gives you 2, A3 gives you 3, A4 gives you 4, and so on. Now, as I said it, we are going to separate this into the odd number terms, right? And then also the even number terms. So I'm going to break it down like this. This is going to be like a piecewise function because we have to give the condition. If n is odd, meaning 1, 3, 5, so you can also make it more clear. 1, 3, 5, so on, so on, so on. And then this right here is if n is even. And you can also make it more clear, 2, 4, 6, so on, so on, so on. So this right here are the indices of the sequence. Okay, when n is odd, we have to get 1, 3, 5, and the next one. When you have A7, you just get 7. So all you have to do is an is equal to n if n is equal to odd. That's all. So I'll put this down in here. A2025, it's going to give you 2025. That's it. Now, what if n is even though? To go from 2 to 2, here, 2 to 2, and then, yeah, let me just circle it. 4 to 4, 6 to 8, and then this is going to be 8 to 16. Well, here, it's multiplying by 2, so 2 is going to be the base. And the easier way for me to do it is look at this right here. This is 6, this is 8. Well, we know 8 is the same as 2 to the third power, so let me just write that down. So A6, we have to get 2 to the third power. Right here, A8 is 16. 16 is 2 to the fourth power. Pay attention to the powers. 6, you should have 3 for the power. For the 8, we should have 4 for the power. So just divide it by 2, right? Here we will have 2 for the base, and then the n is going to be for the power, but we just have to make sure we divide that by 2. So for the next one, A10, it's just going to be, if you work that out, the formula, which is 2 to the 10 over 2, which is 2 to the 5th, and indeed that is 32. So that's it. However, I know what most of you guys are thinking now. it's not too much fun if you have to separate the sequence into like the odd number terms and also the even number terms, right? Is it possible for us to merge this into just one single formula? Yes. Let me show you how to do that. Here we go. My idea is that I want to get another sequence that's going to help us to make sure we can just maintain the odd number terms. Meanwhile, get rid of the even number terms. And to do so, we will have to just consider the sequence 1, 0, 1, 0, 1, 0, and so on. Yeah? If I can get a formula for this, then we can just multiply by n, so we can ensure that this will only happen at here, 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 and then all the odd number terms. While when you have the even number terms, it's just going to be 0. And to get a formula for this, you can use sine or cosine, but I know it's not everybody's favorite to use sine or cosine, so right here I'll just do it with algebra. Okay, let's see how we can end up with 1, 0, 1, 0, 1, 0. Firstly though, 0 is the same as 1 minus 1. Yeah. Up to you however you want to do it. Don't say multiply 5 by 0. But the idea is that I would like to start with a sequence. Let's have 1, 1, 1, 1, 1, 1. And this right here is just kind of boring. It's just 1 to the nth power. It's just 1. It's always going to be 1, I know. But what I want to do is, I want to have another sequence, 1, negative 1, 1, negative 1, 1, negative 1. Because later on, if I add them up, they will be 0, 0, 0. I know 1 plus 1 is 2, but I will fix that later on. Okay, to get a formula for this, here remember the index starts at n equals 1. This is our A1 formula. So notice when you go from here to here, it's just multiplied by negative 1. And so on. So that's the base. And then because n starts at 1, the index here is n minus 1. And you can double check. A2, plug in 2 here, 2 minus 1 is 1, negative 1 to the first power is going to be negative 1, and so on. So far so good. And now if you add up these things, you get 2, 0, 2, 0, 2, 0, and so on. Well, of course, we can just add out the formulas. Here we get negative 1. Let's write down the 1 to the n. It's just 1. And then plus negative 1 to the n minus 1 power. But I don't want the 2. I don't want the 2. I want the 1. So all I have to do is divide everybody by 2. And right here, divide that by 2 as well. So the formula for 1, 0, 1, 0, 1, 0, 1, 0 is just 1 plus negative 1 to the n minus 1 power over 2. Alright, keep that in mind. And of course, we should also get the formula for 0, 1, 0, 1. But I'm going to leave that to you for you to think about it. Now I'm going to put things together for you. So this is what we got earlier, and as I said, you should try to get 0, 1, 0, 1, 0, 1, so on your own. And I'll just tell you the answer for this real quick. You should get 1 plus negative 1 raised to the nth power over 2. Yeah, just start with negative 1 first, so the only difference is this exponent part. Alright, this is how we are going to get the an for that. Here we go. An, it's going to be the following. Here, this is when we have the odd number terms. So we want 1, 1, 1 right here, right? So we'll take this right here, which is 1 plus negative 1 raised to the n minus 1 over 2. And we just have to multiply this by n. And then we add. This right here is going to be for the even number terms. So I will just have to multiply 1 plus negative 1 raised to the n over 2 times that formula, which is 2 to the n minus 2 power. And I guarantee you, if you plug in any n values, you will produce the sequence that we got earlier. Now let's do a quick example. Let's do A6. And remember A6 was equal to 8. So let's see. This is 1 plus negative 1 raised to the 6 minus 1 over 2 times the n is 6. And then plus 1 plus negative 1 to the 6 power over 2 times 2 to the 6 over 2. Now you see that this right here is going to be 5. Negative 1 to the 5 is negative 1. 1 minus 1 is 0 over 2 times 6. The first part is gone. And then for this part, negative 1 to the 6 power is 1. Plus 1 is 2. Divided by 2 is 1. So you really just have to work this out. And you will end up with just 8, which checks from what we got earlier. Just like that.